Okay, this is the second part of the video from this Friday here. I'm going to refer you real quick to page 567 in the book. The kind of rate law that you see on the screen here, like rate is equal to constant times concentration to a power. Perhaps I should write on here because I didn't when I previously did this. This is what we call differential rate law. And it's what we normally just call like the regular rate law usually. There is a form called the integrated rate law that has time in it, and we'll deal with that later. So the one problem that I kind of need to teach you how to do is the problem of initial rates. And the reason that we use the rates right at the start is also summed up on 567. If you look at the second bullet down under that little summary in that peach, we have come to the conclusion it's a peach colored box. We have to look at reactions at the beginning of the time. We have to look at the beginning because as time goes by, we got two problems. Number one, the rate tends to go down and level off as the concentration gets less. The second problem is if the reaction is reversible, then as we build up more product, it tries to go to equilibrium, and that cuts down the rate, makes it go to zero. So we really have to measure the rate, if we're going to do it this way, right at the start. We got to measure it right off the start, and this is one of the techniques that you can use. We're going to do another one next week in the lab where you just measure it for the whole time. So we will then move on to page 569 real quick. And there's a problem there that I want to show you how to do that is described at the bottom of 568, top of 569. Excuse me. And this is called a method of initial rates. And our task here is to try to determine what the rate law is. So if you look at the reaction, it's got ammonium ion and nitrite making nitrogen and water. And what we do is we compare it to the experiments. We try to have a controlled variable. And looking at experiment 1 and 2 together, you'll notice that they kept the NH4 at 0.1. But they did allow the NO2 negative, the nitrite ion, to be doubled. Well, here's what this basically simply means. That allows us to get the order with respect to the NO2 negative. You'll notice they doubled its concentration 2 times, went from 0.005 to 0.01. The rate, if you look at it, went from 1.35 times 10 to the minus 7 to 2.7 times 10 to the minus 7. So the rate also doubled. Anytime you have a double causing a double effect, that's first order. So we would know that our rate law is always going to have rate equals K times whatever the chemicals are. We now can fill in this 1 on this power for this. Now in a similar manner, if you look at experiment 2 and 3, the ammonium ion was doubled. It went from 0.1 to 0.2 between those 2 experiments. But the 0.01 of the NO2 did not change. So this allows us to look at the effect that NH4 plus is having because it's the only one that changed. And it also doubled and caused a doubling of the rate. So that means the NH4 plus 1 is also first order. And so here's what we say. Here's how we say it. The rate law for this, that is the differential rate law, is the rate will be equal to the rate constant multiplied by the concentration of NO2 negative to the first power, multiplied by the concentration of the ammonium ion, NH4 plus, to the first power. So it is first order with respect to each of the 2 chemicals that are in the reactants, but we also say this, the reaction overall has an order because there's a 1 and a 1 for the 2 orders. It is second order overall. So back at the end of the chapter on 602, I believe it is, in 603, there's a problem there, number 23, that has an answer in the back that you could check, and I would recommend that you try to work that one out. And also, it has 2 parts to it, and actually the second part is very easy if you get the first part right. The first part is to go through all the experiments and get this rate law, like we just did. And this one is not very hard. It has some similar results to the one we have here. You can check those answers. To get the K value, that's what they ask you to do for part B. Here's all you do. You will, when you get done, have a law that looks like this. It's going to have rate equals K. It's going to have your chemicals in it. They're going to have a coefficient. Like I said, coefficient. I said it earlier, and I didn't mean to. It's going to have a power on there in order. All you do is pick any of the 3 experiments that are in that box and plug in the rate, plug in the concentration of the one chemical, plug in the concentration of the other chemical that's given in the data table. The only thing you don't know is K, so you solve for it. Next week we'll need to get into a little bit about the units of K and where it's coming from, but for now I'm not going to worry about that too much. So hopefully that will get you started on this, and we'll deal with it next week.